Hello and welcome to the second episode of TidyX, where we go through and explain what we think is a really cool submission for the prior week's Tidy Tuesday project. My name's Ellis Hughes. I'm a statistical programmer at Fred Hutch Cancer Research Center in Seattle, Washington.
And I'm Patrick Ford, and I do data analysis in sport.
All right. So this week's submission, this week's data set is The Office transcripts.
Yep, yeah. So The Office is a TV show. Fun. Have you ever watched it?
I actually tried watching it, and I didn't really get into it, but I know a lot of people are really into it.
It is really good. This is kind of a fun one. We're doing this. We're self-quarantining, so we're in two different locations. Have you washed your hands before the show?
Oh, very much so. Have you?
Yeah, good. Yeah, okay. So we're clean. So the data set this week came from it comes from The Office, which is a TV show, quite funny. Steve Carell runs an office as a spin-off of the British version, which was Ricky Gervais. The package is called Schrute, named after one of the more interesting characters in the show, Dwight Schrute. And basically, the package gives us every show episode and all of the text, the transcripts, and the dialogue from that show. So that's what we're going to be analyzing and looking at today.
Yeah. So the actual post that we're looking at is from Robin. So she posted this great submission doing sentiment analysis of the transcripts. And so we thought that this was a really cool way of showing how you can go and take this word data and turn it into a different way of looking at it. And so she created this bar plot, this horizontal bar plot of emotional charge of dialogue. But then she also created this great word cloud, which I think is a lot of fun to look at. There's not a whole bunch of data that you can get out of that, but you can definitely see. It's fun to see, what words are most positive and most negative that were in the Office scripts.
Yeah, cool. Let's get into it.
Let's take a look at her code. All right. So this is Robin's code. She put it on GitHub, so it's available for everybody to get to through her Twitter posts. So let's, I guess, look at the formatting and the way that's laid out. So it looks like that she's using an R script. So she is using comments here to lay out the different sections of her code, which is great. That really helped us come in and understand what each part was supposed to be doing. So we could easily look at this high level section here where she's asking a question and then she answers it right there.
Yeah, this is something that we saw in episode 1 as well. When dealing with an R script, this is really good, particularly, like myself and like yourself, if you work with other people and you're sharing your code or they have to replicate what you've done, the more clear you can be about what's taking place in each section or each chunk, it really, really streamlines the process. And again, this is just an R script. We'll see in the example that you did this week, you used a markdown file, which kind of delineates these borders a little bit more and then can be transitioned into sort of like a shareable document. And we'll kind of go through that in a little bit towards the end of the episode.
All right. Well, then let's get into the actual code itself. So at the very beginning, as you can see, she's got this setup section here where this is where she's loading in the libraries that she's going to be using, as well as the data and, just an initial look at the data itself. So it looks like she's loading, a number of libraries here. And I have to admit that that's how I tend to do things as well. There's a number of what appears to be tidyverse packages. So a potential alternative would have been to call library tidyverse as well. So as opposed to calling all of those, you could have done library tidyverse. And then it would make it easier to not have to load in a number of these packages. One thing to note is this is perfectly fine to be loading only the packages you need as you need them. Loading tidyverse does load in, a number of other libraries. But if you're trying to limit your dependencies as you're going through, if you're working on a project, doing it this way works great.
Yeah, the dependencies can be a pain in the butt sometimes.
Exactly. And then also one unique thing about the tidyverse is, so she's only using dplyr here, but there's another library called plyr. And you always want to make sure that you load the plyr library before dplyr. There's what's called namespace collisions with those, and dplyr has the better version of those functions. And so that's what you'd want to be doing when you're going through there. All right, so next then she loads in the data using the readr, read CSV, and she's using this long slug of a URL to be pulling it in from the Tidy Tuesday data set. You can also use the Tidy Tuesday R package that I developed, where she'd only have to put in the year and the week, but it also loads some additional information as well. And then she's using Shroot to bring in the Shroot, create the Shroot data set. So let's run these. So she's loading everything. Looks like I've got an old version of word cloud. Loading in the data. All right, so now here she just took a brief look at the data using glimpse.
Mm-hmm. So this is like string str. If you were in base R would be str, same type of concept.
Mm-hmm. And so you can easily see like the column names, some a sampling of the records there, the types. So it's a really good way to get a quick idea of the data that you're looking at. All right, so the next bit is she tokenizes her data set using, so she takes Shroot and throws it into this TidyText function called unnest tokens. Patrick, do you want to maybe explain a little bit of what that does?
Yeah, so that function, unnest tokens, it comes from the TidyText package, which was developed by Julia Silge and David Robinson. And it's actually a book. You can read it for free on the internet on tidytextmining.com. We could put a link to that in the on the YouTube show notes. The basic premise behind unnest tokens function is that it will take the sentences and basically parse them out into single words and make each word its individual row. So if we want to see like a simple example of what this looks like, I wrote just kind of a simple walkthrough of the process here. So if we scroll down, I loaded tidyverse at the top on its own, but if we scroll down, we can kind of run that chunk there that says create data. So this, I just created 5 lines of some basic simple sentences that mean nothing, but just kind of there, I suppose. And I'm going to use the unnest tokens, and it takes 2 arguments, that function does. It's going to take the first argument is going to be what I want the new column to be called, and the second argument is what the column that houses the sentences that I'm trying to parse is named within the original data frame. So the data frame has that column called text, and I'm going to parse that out using the unnest token. And the last thing I did there was I threw in a function, I threw in a mutate, and I turned all the words into lowercase. And so this is just a useful kind of practice to do when dealing with text, because if you're trying to then join out or merge to other data sets, you don't have to worry about case-sensitive issues.
All right, awesome. Thanks for that. So as you can see, it took the data set that was a bit smaller. Shroot used to be 55,000 rows. Now it's 570,000 rows. So it definitely makes your data a lot longer. And so you can see there's this new row, or excuse me, new column called Word, and it's got everything laid out there. All right. So now what we do, or what she's doing is she's using stop words and using an anti-join. So an anti-join, so there's a few different ways that you can be joining 2 different data sets together. So the most common ones that I use and that I see are a left join, a right join, and an inner join. And so those use this by column here to look at where records are the same and combine the data sets. But a useful thing to do in what's happening here is an anti-pattern. So rather than trying to find all the cases where they're the same and keep those, it's actually finding all the cases that are the same and dropping them from the data set. And so there's stop words, which is from TidyText, identifies words that usually don't really have much meaning. It's like able, like there's nothing really direct about it that is going to inform the positivity or negativity or any other information about your text. So those are being removed with this anti-join pattern here. Excuse me. There we go. All right. So now tidy.token.shroot is a little bit shorter. It's 169,000 rows as opposed to the original 570,000 rows. So as you can see, there were a number of words that were stop words in that data set. And here, taking a quick look at the top word counts, and it looks like yeah is the most common word in the data set, followed by hey and then Michael. So
a second step here could also be once you've anti-joined out stop words, you could also kind of look through maybe the top 20 or 30 words being used, and words like hey, yeah, and things like that, or hey, words that essentially might have no meaning within the analysis. You could create sort of a string of those texts and then further anti-join those out and get rid of them as well, so that you're left with things that might be meaningful.
Exactly. All right. So now we're getting to the first plotting section here. And so what's happening here is tidy.token.shroot is then being sent into a count. So she's counting the number of times a word appears and then using a filter to remove remove any words that don't occur more than 400 times.
Yeah.
Right, because the count generates, let's take a quick look. Oh, all right, so it's right here. All right, so it's generating this data set here essentially and looking at the column N, and if it's less than 400, it removes it. And then she throws it into another mutate where she does a reorder of word based on N. So I think that is generating a factor. Is that what that's doing?
She's just reordering so that the words, the highest counted words are at the top. It'll be probably, it's going to help her with the plot here because it's a column plot. If you didn't do that mutate, you'd probably end up with something like, the words would be ordered alphabetically, I believe.
Yeah. Because so it would be ordered alphabetically, which doesn't really give us much meaning. Yeah. We care about the order in which the words show up in terms of their frequency.
Yeah.
So then it's being thrown into a ggplot where she's setting the aesthetics of her ggplot to be the x-axis to be word and the y-axis to be n, or the count. She's then saying, okay, I want a column data set, remove the x labels, do what's called a chord flip or coordinate flip. So it's going to rotate at 90 degrees. So it's going to be horizontal. And then she's setting a theme. So that's like the styling of your ggplot. So you can always set your theme as you go for your ggplot. Some people have very strong opinions about about how things should be visualized. And so
one thing I think is interesting, though, to go back to the code, is she does call each individual package prior to every function, which you don't really have to do. Actually, the time when you would do this would be what we talked about in the beginning, where let's say you were using an older package like plyr, which might have some functions that cross over with dplyr. I might not explicitly load the plyr package, but if I knew I needed something from that, or I needed the function to behave a certain way, I could put plyr : and then the function and get its behavior the way that it would be in the plyr package. But here, these, I don't think, I don't know, it's not necessary to actually, explicitly say the package directly before each function. I don't know if you have any thoughts on that.
It's a good thing to do when you're worried about conflicts. So there's also a package called conflicted that it was written by Hadley and Co. that you can use at the very beginning. If there's a version of a function that you want to use, but you loaded a library that overwrites it, you can tell your R session to be using a specific version of that function as well. So with the way namespaces work in R is a little funny, where it's whichever the most recent function, or excuse me, the most recent package that you load, that's the version of the function that's going to be using. But you can use conflicted or those double colons there to specify this is the version of that function that I want to be using, and it's a really helpful tool to be doing. As you can see here, it makes it very clear which packages we're expecting to be used, or expecting to be using in this situation here. All right. Yeah. So I think this was a lot of exploratory, trying to understand what the data was going on, because now we're going to get actually into the sentiments and actually generating plots that we saw in the Twitter post. All right. So next, what happens is the sentiments get loaded from the Bing lexicon using the get sentiments function from TidyX. And so there's a number of lexicons that are available. There's AFIN, Bing. I'm not going to attempt to pronounce that one, and NRC.
Lockrin, I think.
Yeah, something along those lines. And so these are predefined definitions of positivity or negativity of a word based on those lexicons. And lexicons are important because those, in what context the word is being referenced, can impact whether that word is positive or negative. Say you're reading a financial report, one word could be completely neutral, but then reading it in, your favorite fantasy novel, it's going to be completely different context, therefore completely different meaning, right? So here it's going to bring in a data frame where it has the word and the sentiment, whether it's negative or positive. So yeah, she does a glimpse there, and quick unique on the different types of sentiments. In this case, it's only negative or positive. So then what happens is she takes tidy token shroot, does a left join with sentiments. So she joins by word to add sentiments to that data set, and does a count by episode name and sentiment, and spreads out the data. So it would be normally long, but now she makes it wide by negative and positive, and does a mutate to get the cumulative sentiment. So she adds all the positive records and all the negative records and subtracts the two. And then she ends up with a data set that has, what episode and how positive or negative the words are within it. All right. What happens next? So it doesn't, does that get used later on? Doesn't look like it does. So that was just looks like an experiment to kind of see what was going on.
I think it's used later on in the point, the ggplot.
Okay.
Looking at how sentiment influences show ratings, I believe it gets joined in later on.
Gotcha. Okay. Cool.
Yeah. Let's see.
All right. So then, it looks like there is another set here where she used tidy token shroot and does an inner join. So an inner join keeps only the cases where the column that you're going to be searching upon, which is going to be a common named column, only cases that match between the two, right? And then it does a count on word and sentiment. So we've reduced the number of rows because we only kept the cases where sentiment was positive or negative and did a count on that. All right. So here she does some pre-processing before she goes into the ggplot again, where she removes all the cases where the word isn't listed more than 150 times. If it's negative, she applies a negative value to the count, does a reorder based on that word, and throws it in. So then what's interesting is she actually assigns the output to P1. So this is how you can then keep the ggplot object from printing. So it didn't go to my plots window on the right there until I actually printed P1. So that is a way to store your plots without having the output show up. So as you can see, bad is listed a lot of times, and it's a negative word. And then love, is listed nearly 750 times.
And here's the word cloud.
Ah, yes, the word cloud.
Yeah.
Okay. So what Robin's doing here is she uses the function PDF to then tell it to, okay, everything that I print after this, I want you to write to a PDF. And she sets the width and height of the PDF to be 4. So I think that's 4 inches by default, or the units is 4. Yep. And then she sends Bing word counts into this function acast, which I don't really use very often. And Patrick, I don't think you have.
I think acast comes from the reshape or reshape2 package. It's another function. I think earlier on she used spread. It's another function that you can use to go from long to from a long format data frame to a wide format data frame. So in this instance, she's taking the Bing word counts data frame and she's applying this acast function by specifying that she wants the word in the new data frame to be each individual row. Then the tilde tells us that the sentiment will be the column, and the value that's going to fill in underneath those columns is n. So that'll be a count, the count from the Bing words count data frame. And then she specified fill to equal 0. I think normally in acast, the fill will default to NA. So she just gave it a 0 value.
Mm-hmm. Yep. And then she's feeding it into this function comparison here. So let's quickly take a look at what this looks like. All right. So yeah, that's exactly, as you described it, right? So each row is word. I think this is, let's keep scrolling up. It's a long data set. All right. So yeah, negative and positive.
Yep.
Cool. All right. So then that goes into this function comparison cloud, which is from the word cloud package. And she's assigning a color to, and these are hex codes for just defining the colors of negative and positive. So this would be the negative color and this would be the positive color. I'm basing that based off the matrix here, so that's negative and positive. And then she's only going to list 100 of those words. So, hey, there you go, on the right there. It doesn't look like it's showing me all. Oh, it's probably because my view was too small. So let's rerun that. Yeah, there we go. Yeah, it's because my window is too small. All right, and then dev off tells it to stop listening, take all those outputs, and drop it into the PDF. Cool. So then one interesting thing here is, so Robin used a full path to define where she wanted the PDF to be written to. And this works when you're working on your own little projects. In fact, I used to do this all the time. But if you're using an R project, so if you're using RStudio and you set up a project to be working in, a nifty little package that'll make it so you don't have to write your full path is the here package. So it's spelled like that, each here, right? And so then you could call library here, helps if I spell it correctly, and then you can just do here, and then do your path here. And this will then write the equivalent to that full path for it to then record the PDF to, but this also makes it then transferable. So as it is, see, I can't run that function because I don't have that path on my computer because it's going to Robin's path. But if you'd be using the here package, it would then look for the project, the highest level of the project, and go from there. So it makes it really nice for being able to share your code with other people and not having them have to understand the paths that exist.
Another option would be to show the have the plot print out to the little plot window there, And when you're working with ggplot, you can do a ggsave, and the ggsave function will automatically save whatever plot is in there being displayed directly to your whatever your working directory is. The other thing with ggsave is if you didn't want to save it in PDF, you could save it as like a JPEG file. You could save it as an SVG, so it could go to a web page, things like that. So you can also have a bit of flexibility in how the type of file that you're trying to save as.
Yeah, exactly. All right, so cool. Now we're gonna move on to here. I like how she already answers this question for us right here. Is there a relationship? So what she's doing is she's taking the Office ratings data set, pulling out season, episode, renaming title to episode name, and the IMDb rating. She scrapes that out, creates a new data set, then performs an inner join. Once again, only keeps the cases where they match. So she's grabbing the Schrute sentiment data set that she created earlier and keeping only the cases that they match by episode name, and turning season into a factor. So she ends up with this data set here where she's got the episode, the sentiment of that episode, and all the other various information that she had going forward. Mm-hmm. So then she throws it into ggplot, where she defines data as that rating data set she just created, and has the aesthetics of X being the sentiment and Y being the IMDb rating. And she's coloring it by season so she can look to see whether there's a relationship. Kind of looks a little bit all over the place, so that jives with what she said earlier about there not being much of a relationship between that, but that happens.
The other thing you can notice there is, and in this one, she didn't explicitly set the theme, right? So before we had theme _ minimal, which made the background of the plot to be that white kind of color with some with minimal grid lines. This is the default ggplot theme, which is this gray with the white grid lines.
Mm-hmm. So, like we said, some people have very strong opinions about formatting those. Do what feels right. Yeah, but I mean, this is all part of exploratory data analysis and trying to understand your data. Is sometimes you have a theory that, I bet you there's a relationship between the sentiment and, the IMDb rating in this situation here. And it didn't turn out to be the case, but that happens a lot. That's just part of data processing and going through it is just getting to know it better. All right, so she takes another. So moving on to descriptive figure of positive and negative characters. So this is now the plot that she put onto Twitter. So a lot of this beforehand has been also exploring the data and making sure she understands it. He's taking tidy.token.schrute, joining the sentiments like she did earlier, getting a count by episode and sentiment. Spreading it out by positive and negative, positive and negative, and tough to say all that quickly, and then generating a cumulative sentiment. So it's the same process as been happening earlier. So episode, sentiment, C, negative, positive, neutral. Cool. So we've been doing that. Now she instead calculates it by character. So she takes tidy token Schrute, does an inner join with sentiments again by word, but this time she does it by character and sentiment, and goes, okay, now which characters have the most positive and negative words? Then throws it into, she does some pre-processing where she keeps only the characters that have at least 300 words, it looks like, based off of this, and then creates a dummy variable. So this is then going to define the color, and it's like, okay, is this character more positive or more negative? Just overall, looking at if sentiment C is greater than 0.
Yeah.
Or less than 0, excuse me, the way that carrot's going. And then does, once again, a reorder of character based off of sentiment C to make sure that it doesn't try to order the characters based off of alphabetical order, but based off of the sentiment C. throws it into a ggplot where she then defines character as the x-axis, sentiment C is the y-axis, and fill, which is defining the color of the bar or whatever she's going to be plotting with the sent dummy data set. She creates genome call, which is the columns function, does a chord flip to once again rotate it about 90 degrees. She then used the labs to define the labels of the y-axis, which is emotional charge of the dialogue, positive minus negative words, and X is character. She sets the theme to be theme BW, which is theme black white, and then does some additional edits to the theme here, where she removes the legend. So the legend now doesn't exist on the data set. She's changing the size of the X. I think that's the axis or the label.
Those are the labels. Yeah.
Yeah. So the labels of the x-axis, the title of the x-axis,
Yep.
which is that. Same with the y. All right. Yep. So then let's run that without that last theme there. Change there. So this is the theme BW looks like. So it's fairly similar, but it still has this legend here, which is then gets rid of by legend position. So when you run that, hey, there you go. So it got rid of the legend. It made all the text a little bit larger, so it's a little bit more legible.
She bolded the titles of the X and Y axis. Oh, the other thing I think that I like that I'll bring up, because people always ask this, or seem to ask this, is how do you get two lines on an axis or a title? So if you go in the labs there where she has the Y, she uses that little \n character, and that's what basically defines the two lines that she's trying to type her y-axis title on.
Mm-hmm. It's also known as a carriage return or new line. So /n, think new line. And it makes it pretty easy, at least in my brain, to remember /n is new line whenever I want a new line in there. So you could potentially do multiple of those. Then here she uses ggSave to save her output to the word. So she saves the character sentiment, which is this plot here, as well as the word bar, which is the plot that we generated earlier, the P1. Is it going to print?
Yeah, that's it.
Oh, yeah, that is.
Yeah.
It looks so similar. So she's saving both of these, and see how we were able to then reference it later on in the script here by doing that. So that was a really great way to do that, setting the height and width kind of just based off of the actual, what she's actually plotting.
Yep.
And then one thing that Patrick and I thought that was really great, we'd suggest people doing going forward after they hear this is, listing the techniques and functions that she learned.
Yeah.
We thought that was really nifty, because the whole point of this project, right, is to get people to be, practicing their R programming skills, and they get to, practice on different data sets, and that means dealing with new things.
I think it's also good because it kind of gives you a catalog. Like sometimes I'll be working on a project and I'll be like, oh man, how can I do this? And I'm like, oh, you know what? I did that in project X a year ago. So then I can kind of go back and see what I did to wrap my head around maybe how some of the code worked and stuff like that. So I thought that was pretty cool. And then I think the one other thing that I'd highlight about this one before we move on to your example is one of the things I like about R that I think makes it really useful is the ability to take a data frame and use the pipe operator there from Tidyverse or from dplyr. Use that pipe operator to basically iterate over there, or basically work over that data frame, create new variables, reorder things, create join things together, and then in one add another pipe operator and automatically go into iterating a plot. And I think something like that, that's one of the values of R, in my opinion, is that I can really quickly work through a data set, iterate over it, get things I need, and very quickly begin to create plots and visualizations of the data to start to kind of draw meaning and get an understanding of maybe how I might want to analyze this, or maybe questions I might need to ask from a domain expert, or something like that.
All right. Well, thank you so much, Robin, for letting us go through your code and explain it to everybody. We're now going to take this same concept and apply it to a new data set of going through and, doing sentiment analysis and generating a word cloud. So, all right, here we go. So what I did is when I first saw this, I got really excited because I remembered a Tidy Tuesday that we had last year on wine. And I think most people that know me know that I really enjoy my wine. I enjoy, going out with some friends and really thinking about it and describing to each other, what do we taste, what do we smell, and all that. I mean, a lot of it's a little pretentious. I don't think you need to be as uppity about wine as a lot of people are, but I still really enjoy it. So the way that I went about this is I used an R Markdown document. So this takes a little bit different format than an R script, but it accomplishes a similar thing in that we still get to run all of our R code. So the format of an R Markdown is, so it's what's called a YAML up at the top here, where I describe what the title is, who wrote it, when they wrote it, and what the output type will be. And so this will become important later on, so we're going to skip that for now. But the nice thing is that it allows us, similarly to the way Robin did it, where it was laid out with a setup, then, okay, now I'm going to do this step, now I'm going to do this, sentiments. I'm able to do the same sort of thing with an R Markdown, but it makes it really, really clear what's going on for anybody that comes into my code. So at this step here, I'm simply loading all the libraries that I'm going to be using. And so I'm using the same sort of libraries that Robin is using, so it's probably not going to end up doing much. But there's this one library here that wasn't used there. It's called Tidy Tuesday R, and that's actually a package that I wrote. And what it does is it performs this task here for us. It'll help us load in the data. So the wine magazine ratings come from Wine Enthusiast. The Tidy Tuesday that used it was in 2019 in week 22. So we can then just simply click on that. So it's now going to reach out to GitHub, identify the files that it should be downloading, and download them for me. So I don't have to worry about finding that long slug of a URL. It pulls it down for me and downloads it all for me in one step. And then when I print it, it actually brings in the nice README that Thomas generates for us. So I have all the information in me. I didn't have to leave my RStudio session to do that, which, I mean, I'm a little bit proud of myself for doing that. So now we're going to go through and we're going to follow the same sort of technique that Robin did. So we're going to take the wine mag ratings and we are going to unnest the descriptions. All right. So we're going to generate a new column called word and use the input of description. So description is what the wine reviewers were describing the wine as. Right, so it is this here. So some of them got a little bit wordy. So this data set is rather long, or at this point it's not very long because we haven't unnested it. But I also decided to combine all the processing into a single pipe. So I do my unnest tokens and anti-join in one step. It's up to you how to do it. And then I used a glimpse at the end there just to make it a little bit nicer. Glimpse will still, you can throw that at the end of your pipes and it'll still assign the full output to your pipe there. So that's a kind of a nice way to be viewing things without printing everything out. So yeah, so we've got 3 million, over 3 million rows. So it's a large data set. So then I also used the Bing lexicon I wasn't sure if there would be a different one to be using in this situation. There might be a better lexicon to be using, but I thought this was good enough for now. So I can either run it interactively as we do normally with the R scripts, where you just run each line, but you can also just click these arrows if you want to run the entire chunk, and it does the exact same thing. So I think that's pretty nice to be able to have those two options as you're going through. If you don't want to go through and click run for every single line, you can just click the play button and have it run everything. The next step was I was curious, what were the most common words that were used for describing lines? So what I could have done is I could have gone and done so in this case, I did a group by and then summarize. That's very similar to the count function that was being done earlier, but I was also curious what the sentiment was, which I couldn't have grabbed via the count. So I pull that out, and here are the top 10 words that were used in describing a wine. So
what was the in the summarize there, you have the first function wrapped around sentiment from the data frame. Can you go over what you did?
Yeah. So the first is a function. It's a helper function that was written that'll grab the first record. So when you're running a summarize, it was recently updated to allow for records of more than length 1 to exist, but up until very recently, if you're using a summarize, the record that came out had to only be a length of 1. So the first is just, it's a helper function that'll just grab the first record there. So if you know that there's only going to be a single instance of the value of sentiment, you can just tell it to grab the first record for you. So here's the first 10 or the top 10 words that exist in the lexicon there. But what I think is interesting is lemon, when describing a wine, is actually tagged as a negative word. And so this might mean to me that this lexicon might not be the best to be using, because I think describing a wine as lemony or that it has a lemon taste might not be a bad thing. But
I wouldn't want a very lemony wine. I don't think I want a lemony wine.
No? Okay. Like a citrusy, like bright and crisp. I think it could be good. But in this situation, it's considered a negative. And so if I were to come back to do this another time, I want to think more about the lexicon that's being used for this. And so next, I am going to go through and calculate a score sentiment. So now I'm curious, is there a relationship between the sentiment of the description and the score that was assigned to it? So I go through and I do similar to what Robin was doing, where she was grouping by character. Here I group by points. I get the sum of the negative words for points as well as the positive words that were there, and then I tried to normalize it by the number of words that exist, and then calculate the score from that. So now I end up with a data set which is points, and then finally sentiment score. So it's going up from 80. So 80 is the lowest point score you can get, all the way up to 100. And so it looks like it seems to be following some sort of trend. So now I'm going to throw it into a ggplot, where I'm going to use a similar sentiment dummy. Is it more negative or more positive? I'm going to convert the points into a factor. One thing that I did is I like to define my X and my Y and my fill, rather than just ordering points and then points, comma, sentiment score, comma, fill equals sent dummy. I prefer to do it this way, because that way if there's any changes to the aesthetic, the AES function, it'll always know that points is to be assigned to X.
Yeah, that's a good point. I do the same thing. Most of the time when I use a function, I actually will try and write the specific arguments out. So like in that unnest, how you did output and input, I usually do the same thing with most functions is I try and be very explicit about what I'm writing in there. Also, it helps if someone else is kind of taking your code and working through it and might not have as much of a background in R. They can see exactly what's taking place.
Because hopefully argument names are informative.
Yeah. Yeah.
um, yeah. And then I actually use a lot, or I actually nearly identically use the same code that Robin was using for plotting. I just changed some of the wording with the labels, since I wasn't plotting characters and sentiment. I was plotting score versus the sentiment. So let's throw that. But everything else is identical. So
one thing you did do, you used geom bar where she used geom call. If you use geom bar, you do have to set the stat to equal identity. Otherwise, it won't print what you just got there in the bottom right. So that's the only.
Yeah. Because bar, I'll try to, I think, sum up everything for you.
Yeah.
And, so stat is how you tell geom bar how to behave. So since I'm passing identity, it's telling it to use the values that I'm passing to it explicitly, rather than trying to calculate anything else from it.
Whereas geom call, you don't have to do any of that; it automatically will.
Yeah, exactly. So if you look at this, I think there's an interesting little bump around 88, 89, and 87 around here versus the 94, 95 scores is a little bit higher down here. So I think that's a little interesting. And then as you can see, 100, it's fairly well scored by sentiment. But I do wonder whether I used the correct lexicon for doing this, since it was scoring lemon as a negative. So we didn't look at this by varietal, which would then also potentially drive some of this. But like this was supposed to just show that you could use similar code to generate a similar result on completely different data. So that's fun here. All right, so now onto the word cloud. So there were a number of varietals that were listed. They weren't listed as a white and a red and a rosé. So I wanted to break it down by that. So what I did is I went through my data set and I created vectors of here's what are white wines that exist in my data set. Reds is a little bit longer. There's a number of red wines in the data set, and then only 2 ways of spelling rosé. So then I go through and I calculate which words occurred most frequently in white wine descriptions, red wine descriptions, or rosé descriptions. And I go through that by calculating using the case when function. So this looks at first this situation here, and it goes, okay, if variety is in the vector that I defined as whites, then define it as a white wine. If it's found in my red wine vector, then define it as a red. And if it's defined as a rosé, call it a rosé. And then if it doesn't exist in this situation, I said call it other. You could choose to not do that. That's perfectly fine. I just chose to do that. I'm not quite sure why. And then I go through and for each word, I calculate the number of times that it got counted as a red in a red wine description, a white wine description, a rosé, or other. And then I did a gather to take what would have been wide and turn it into a long data set using this gather here. And I go, okay, take the red, white, rosé, and other, and turn that into each of those that would have been columns into a row, call that variety, and then the values that were within those and call that val. In this case here, I decided that I actually only wanted red and white wine, and then I used the reshape 2 acast like Robin did to make a matrix for me.
You could have also used reshape to melt in place of gather. It'll do a long or a wide to long format as well.
Yes. All right. So now I have a data set that looks like that, right, where each row is a word and then it's either red or white wine, and that's the count is the number of times it occurred in one of those in one of those descriptors. Here, I'm doing something a little bit different, and I'm using the par function, which comes in base R. That's for, I'm telling it that I want the background of my plots to be black. And so you can set that once for each of your R sessions, and it'll then revert back to default once you restart your R session. So now I send line word relation into the comparison cloud function like Robin did, and I've defined these two colors. This is for defining red, and this is for defining white. So now when we run that, hey, look at that. We ended up with a fun little word cloud where the words that are found more often in white wine are like a light yellow, and then the ones that are found in red wine are a darker red. And so look at that, lemon is the most common word found for white wines. And so, so what's interesting is that might be then driving some of the scoring that we looked at earlier. It could have been depressing that a little bit because it's considered a negative word. But yeah, this is just a fun way to do that. But I think, as we talked earlier, the benefit of an R Markdown is the fact that we can knit it into an HTML document. So we didn't practice this before, so hopefully this will work. But right now it's actually taking this into a separate R environment and executing all the code that I wrote up that we just went through to generate an HTML document that then you could hand off to your coworker who doesn't really care about the details about R or the code itself and just wants a document to look at. So here's everything that we just went through with the plots listed within them with that nice word cloud for you right there.
And so, within those chunks, you can also specify like echo equals false or include equals false. And those will do things like remove text. So for example, there, if you did echo equals false, right, that's going to, when he knits this, it's going to remove all of the R script and only provide the output, which is in this case the word cloud. So if you were making and include, similarly, if you did include equals false, that would remove the output. So
you don't want to do that.
Just a cool way to make really turn your work into a quick, easy report that you could then, if you click open in browser, it'll open up into a web page. You could put this, this will save into your working directory as an HTML file, so you could email it out to coworkers if you're working on a project or things like that. So, yeah.
Well, I think that is everything that we needed to go through. Thank you very much, Robin, for letting us go through your code and explain it to everybody. If you could please take the time to review and comment on this video with what you like. If you could give it a like and then follow Patrick and I on Twitter. You can find me at Ellis_Hughes.
And me at OSP Patrick.
Thank you so much for listening, and I hope you have a great rest of your day and keep it safe.